Hi guys. I believe we're going to start topic 7 now. In the first lesson in topic 7 is on the distributive property. You guys have already learned about the distributive property previously, but now we're going to give you some key terms, and then we're even going to bump it up a level by showing you some exponents with it as well. So if you just follow along with your notes, and you'll be able to fill in all of your blanks. So for your first vocab word, you learn about variable. And a variable is a symbol, usually a letter, used to represent a number. The most common variable that's used is x. You'll also see it's used as y, but you'll also see any other letters that have been used for it. But those are all just letters that are usually represented by a number. Okay, the next vocabulary word that you need to know is term. Term is a number, a variable, or a product / quotient of the two being added, subtracted in an expression. So here is an example. There are 4 terms in the following expression. 1, 2, 3, 4, because there are 4 things being added, subtracted, multiplied, or divided together. If you look here, if you want, you can even circle each one. Those are the things that are being added and subtracted together in an expression. Okay? Then you have the next term or vocabulary word being called coefficient, which you guys may have learned about in a science class previously, or maybe last year's math class. But a coefficient is a number that is multiplied by a variable. Okay, so in the term 2x, the coefficient is 2. All right? And then if you look here, it says in the term x, the coefficient isn't written, but it is being implied that the coefficient is 1. Remember how I said mathematicians can be very lazy sometimes. If I'm just representing the value of x, it means I just have one x. So instead of putting the number 1 in front, they just leave it as x. But ideally, the coefficient is 1. Okay, and then our last one is called the constant. This one is a term that does not contain any variable at all, and it never changes. An example of a constant here, it says blank is the constant in the following expression. Well, for here, we have a coefficient of 1, and the constant is actually going to be a 4. These are the numbers that I say are constantly alone. They don't have any variable with them. Okay, so those are all of your vocab terms that you should remember for when it comes to this topic. If you scroll down, we can start working with the distributive property. And we've done this in the past, so this should be somewhat of a review for you. When you're using the distributive property, you first have to multiply the outside term by all of the inside terms. Always include the sign in front of the number in all solutions, okay? So when I multiply this out, negative 13 is what's being multiplied to my problem. So when I write this out, I'm saying that negative 13 is being multiplied by x, plus negative 13 is being multiplied by 2. So then when I solve this out, I have negative 13x plus negative 26. Or you could also say negative 13x minus 26. Because we can't have two signs together normally, we always bring that down to one sign, and since they're different, that means subtract. So negative 13x minus 26 is going to be your final solution. Both solutions are the same. You can use this one as well, but this one is more commonly used because we don't like the two signs together. Okay? Then we're going to go ahead and move on to the next one. The next one has a fraction in front. So that means I'm going to have to multiply the fraction to everything. Okay, so I'm going to do 1/2 times my negative 5y minus my 1/2 times my 10. Okay, when I do this, 1/2 times negative 5y is going to give me negative 2.5y. Or if you want, you could say negative 2.5y minus 1/2 times 10. That's just half of 10, which is just 5. All right. And then if you look at the next problem, you'll see that this is where the mathematicians get very lazy again. So there's a negative sign in front, but there's not a number. Usually that means that it's just the number 1. So if you look at this, it's negative 1 times 3g minus negative 1 times 4. So I'm going to rewrite it as negative 1 times 3g minus negative 1 times 4. So when I do this, I get negative 3g minus negative 4. But then once again, we have the two signs together. So I'm going to rewrite this because two negatives make a positive, and it's just going to be negative 3g plus 4. Okay. Either one is fine, but we don't usually like the two signs together. All right. And then the last one, we'll do orange. The last one, it actually has a 3 on the outside and it's on the other side, but it still has to go to all of the numbers on the inside. So 3 is going to go to my negative 1.5x, 3 is going to go to my 17y, and my 3 is going to go to my 2.4. So I have 3 times negative 1.5x plus 3 times 17y minus 3 times 2.4. So 3 times my negative 1.5x is going to give me a negative 4.5x plus 3 times 17y is 51y minus 3 times 2.4 is 7.2. And then if you notice at the very end, I didn't combine any of these numbers together. And the reason why I didn't combine any of these numbers together was because none of them are alike. So I didn't combine my 13x and my 26 because the 13 has an x and the 26 doesn't. I didn't combine my 2.5y and my 5 because the 2.5 has a y and the 5 doesn't. Same thing with my 3g and my 4. They don't have the same variables, so you can't combine them, and you'll learn about combining like terms in the following topics or the following lessons in the future. Okay, so now let's go ahead and move on to the back. We're going to distribute a variable. So the same rules are going to apply with the distributive property. You're still going to multiply the number on the outside, but then you also have to multiply a variable at times. When you are multiplying a variable, when multiplying two of the same variable, that will actually raise it to the next power. And I will show you what I mean by that with this first example. So 7m is on the outside, so 7m is going to be multiplied by m minus 7 times 1. So when I rewrite this, I'm going to rewrite it as 7m times m, which is really 1m. Remember, mathematicians are lazy and they don't always put that 1 in front, minus 7m times 1. So 7 times 1 is just 7, but then we have m times m. So this is where I was telling you it's going to move it to the next power. So that would become m squared because there are two m's there. So m squared. And then I have minus, and then 7 times 1 is 7, and then m is just by itself. So you leave that there. So your final answer for this is 7m squared minus 7m. And you cannot combine these two because this one has two m's while this one only has one. So yes, they have the same variable, but they are not the same amount, so you cannot combine them. Okay, then we have the next one here. Let's do it in a different color. The next one here, it looks like we have two separate distributive properties that we're going to need to do. I see a 5 on the outside of this parentheses that needs to go to everything on the inside of that parentheses. And then if you look, I see a negative 5 on the outside of this one that has to go to that one. So I'll do these both in two different colors. So I'll start with the first distributive property. It's 5 times h plus 5 times 5. Okay, that's the first one. And when we do that, we get 5h plus 25. Okay, and then if I were to go ahead and do the second one, The second one is going to be negative 5c times 5 minus negative 5c times 7c squared. Okay? Now, I kind of went off to the paper, so if you want to go underneath the pink, that's fine too. Okay? Then when I combine these, negative 5 times 5 is negative 25, and I have a c there. And then I have minus, and then negative 5c times 7c squared. So that's a total of 3 c's there. So negative 5 times 7 is negative 35. And then we have a total of 3 c's. So c and c squared becomes c to the third power. Okay, then we're going to look to see if we can combine like terms or if we need to get rid of some signs there, which if you look, we do. So when I rewrite this problem, I have 5h plus 25 minus 25c, and then two negatives are going to make a positive 35c to the third power. Once again, I can't combine any of those terms because this one has h, this one doesn't have anything, this one has 1c, and this one has 3 c's. So I can't combine any of those terms. Okay, and this would be my final answer. Okay, then we are going to go down to applying the common or combining like terms concept in the geometric problem. So I'll show you what I mean here. We are going to consider what you know about the geometric problem itself, okay? Remember, perimeter is the distance around the outside of a figure. And that means that you will have to add all 4 sides together, while area is the space on the inside of the figure. And most commonly seen in squares and rectangles, that would be A is equal to base times height. But in a triangle, it's base times height divided by 2. And if you think about it, whenever you have a square or a rectangle, if you're cutting it in half or dividing it by 2, you'll see that you create a triangle, which is why the formula is base times height divided by 2. But anyway, let's go ahead and do the example here. It says that it wants us to find the area in the rectangle. When I find the area in this rectangle, I have to do base times height. So A is equal to base times height. If I look, the base in this rectangle is 10, and the height is x plus 2. So if you then see what I did there, I'm going to have to do 10 times x and 10 times 2 because I have a parentheses there. So when I do that, I get 10x plus 20. So then that would be my final answer for my area. And once again, I can't combine this because this one has x and this one does not. All right, so this was your lesson on the distributive property. You'll now go ahead and do your activity for the day.